When I say the members of your family, you can't include any other person neighbor to you. The months of a year beginning with the letter J are only January, June and July. So clearly they form a set. All the numbers from 1 to 99 are the numbers which are less than 100, which is a natural number, and hence it is a collection of a set. Whenever any element is inside the set, we use the symbol belongs to. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. And in today's session, we are taking a very first chapter, sets. Now let's see what are the important topics we are going to discuss in today's session. So here we will see what do you mean by set and their representation. That is how we are going to learn groups in the form of a set and how we are going to represent a set mathematically. So, a set is nothing but well-defined collection of objects. So, objects may be any numbers, alphabets, anything in mathematics. Basically, if we take any general examples, the collections of English alphabets, the collection of whole numbers. So, collection is nothing but it forms a group. But when I say a set, it means a well-defined collection of objects. What do you mean by well-defined? Suppose if I take an example of collection of beautiful flowers in the garden. So the idea of beautiful flowers vary from person to person. So here I cannot group flowers into a set. We can't form a set where we can call a beautiful flowers in a garden. But here are some of the examples which we can take. Players of a cricket team, yes, they form a set. Students in your school, they form a set. Members of your family, we form a set. Ovals in the English alphabets, A, E, I, O, U, it forms a set. Prime factors of 10, 2 and 5 forms a set. Odd natural number less than 8, it forms a set. Numbers in dice, it forms a set. So clearly when you see all these examples, we have a very defined property in all the elements inside the set. When I say the members of your family, you can't include any other person neighbor to you. So exactly you have only a family members related to you. So that's why we call set as a collection of well-defined object. So now here we have few mathematical sets also. So for example, natural number is also a set, integer forms a set, set of rational number forms a set, real numbers forms a set. So any system of numbers in mathematics can be termed as a set, and all these sets are denoted by particular capital letters. So when I say N denotes set of natural number, W whole numbers, Z integers, R real numbers, Q rational, and J can be termed as irrational number. Now here, which of the following are sets? Justify your answer. We need to see here the collections and see whether they form a set, and if it is not a set, we need to justify the answer. The very first one is the collection of all the months of a year beginning with the letter J. When I say the collection of all the months in a year beginning with letter J, so we have January, June and July. So all these elements forms a set. We call the members of a set as elements. Hence, the months of a year beginning with the letter J are only January, June and July. So clearly they form a set. The collection of 10 most talented writers of India. So we have a adjective here. So when we have any adjective with the group, most talented, most beautiful, like that. So we cannot describe exactly the property of the collection here. Hence it is not well defined. That is why it is not a set. a team of 11 best cricket batsmen of the world. When I say best cricket batsman, so the selection of choosing best cricket batsman in the world varies from person to person and it is not unique for all. So that is why it cannot form a set. Next is the collection of all boys in your class. So in your class, how many members boys are there? They can form a collection and hence it is clearly a set. The collection of all natural number less than 100. All the numbers from 1 to 99, all the numbers which are less than 100, which is a natural number, and hence it is a collection of a set. A collection of novels written by writer Munish Premchand. So when I say a particular name of a writer, so all the novels written by him will form a set. The collection of all even integer, yes, it is a set. The collection of questions in this chapter, yes, we can form a set. A collection of most dangerous animals of the world, yes, it is a set. Next, conventions in set. So what do you mean by conventions in a set? Then here we learn how to denote a set, how to write a set, how to write an elements inside the set. Now the very first statement says here, sets are usually denoted by the capital letters of English alphabet. So a set can be denoted using the capital letters or big letters in your English alphabets. The elements of a set is represented by a small letters. When I say numbers, it may be objects like numbers, alphabets, variables, anything. But usually whenever we have a letter kind of elements, we usually write with small letters of English alphabets. If A is an element of A, we write A belongs to A. We use the symbol belongs to. It is called as belongs to. Whenever any element is inside the set, we use the symbol belongs to. And say that A belongs to A. Suppose if B is an element which does not belongs to the set, we usually write it as B does not belongs to A here. So that is, we use the symbol does not belongs to and we call it as B does not belongs to the set A. So here are some examples given. If V is the set of ovals, so when I say V is the set of ovals, I should denote the set by V. Then I should write each and every element of V using comma. So when I say the set of ovals, so it is A, E, I, O, U. So this is the set V now. A and B are alphabets. Suppose I take A and B are alphabets. We can clearly say A is inside the set V. That is why we denote A belongs to V. But here B is an alphabet but it does not belongs to V. That is why we usually symbolize as B does not belongs to V. Next, P is the set of prime factors of 30. When I say prime factors of 30, we can write only the prime numbers, that is a factor of 30s. So the only possible factors are 2, 3 and 5. So we have 3 elements inside set P. Clearly you can see 3 belongs to P. 15 does not belongs to P. 15 is a factor of 30 but it is not a prime factor of 30. That is why clearly we can see 3 belongs to P but 15 does not belongs to P. So this is how we will denote a set using the capital letters. We will write the elements inside the flower braces. We will separate each element with commas. And when I say about the order doesn't matter in writing the elements of a set. I can write it in the form of A, E, I, O, U or I, O, U, A, E. But always remember, element once written inside the set cannot be repeated again. You should write only once of every element here. Let A is equal to 1, 2, 3, 4, 5, 6. Insert the appropriate symbol belongs to or does not belongs to in the spaces. Now here set A has the elements 1, 2, 3, 4, 5, 6. We need to insert a proper symbol. If the elements belongs to it, we need to put belongs to. If the element is not inside the set, we need to put does not belongs to. So now clearly 5 belongs to A. 8 does not belongs to A. 0 does not belongs to A. 4 belongs to A. 2 belongs to A. 10 does not belongs to A. Next, representation of sets. We have 2 types of representing a set. So one is to write all the elements inside the set and the other is just describe the property of a set. So here we have the two types. One is roster or tabular form, set builder form. So roster form means when I say vowels in English alphabets, we can write the elements separately using comma, that is A, E, I, O, U. And when I say set builder form, we are describing only the property of a set. We can just write as vowels in English alphabets. So vowels in English alphabets. So like this. So if we describe the property inside the set, it is a set builder form. If we write each and every element of a set separated by commas, then it is called as roster or tabular form. So let's see now what is roster or tabular form. In roster form, all the elements of a set are listed. The elements are being separated by commas and are enclosed within the flower braces. As I already told you, a set is always written inside the flower braces and the elements inside the sets are separated by commas. So here is an example. The set of letters forming the words school. Here is a word school here. We need to write the letters of school in one set. So when I say, when you are repeating the elements, do not repeat it twice. You need to write every element only once. So S, H, we have two O's. When I say letters of the word, we have O already inside the set. No need to write it again. So just break it and write L. So this is the set. So here we are writing S, C, H, O, L in roster form. Next. Set builder form. In the set builder form, all the elements have a common property that can be described in a set form only. So how we will define it? Here example is taken. We will denote the set with a capital letter. We will take X such that X is a natural number and X lies between 3 and 10. So this is how we will describe the property of the elements of the set A. We'll say X is a collection of all X, where X is a natural number and it lies between 3 to 10. When I write this in roster form, the same set can be written in the form of, since X is all those numbers between 3 and 10, we can write 4, 5, 6, 7, 8, 9. See the difference? So this is your roster form and here we are describing the property of these elements in set builder form. Now let us take few examples of writing sets in roster form as well as set builder form. So here is an example. Write the set where X is a collection such that X is a positive integer and X less than 4 in the roster form. Clearly we need to write a set. We can denote it by any capital letter. We need to write a positive integer which is less than 4. What are the positive integers? 1, 2 and 3, and clearly all these elements are less than 4. So we are writing the set builder form into roster form here. Next, write the set A 1, 4, 9, 16, 25 in set builder form. Clearly observe the elements of set A, they are all perfect squares. So how we can write here? So we can write set A such that X is a perfect square. So this is how we can describe the property, or we can write set A is a collection of all X such that X is equal to n square and n belongs to the set of natural number. Like this also we can write, because X is a perfect square number, you can take the values of n belongs to n also. Next. Write the solution set of the equation x square plus x minus 2 is equal to 0 in roster form. We have an equation here. We need to write the solution in the form of a set. So first let us solve the equation. We have x square plus x minus 2 is equal to 0. We can write this as x square plus 2x minus x minus 2 is equal to 0. So x common, x plus 2 minus 1 common, x plus 2 is equal to 0. We have x plus 2, x minus 1 is equal to 0. That is x is equal to minus 2 or x is equal to 1. So we have two solutions. Let us write this in solution set, that is x, set x is equal to minus 2, comma 1. So these are the solutions. Minus 2 and 1 are the solution of the given equation in roster form. Next. Write the set 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7 in set builder form. They have given the elements in roster form. We need to write it in the set builder form. You can clearly see the denominator precedes by 1 with the numerator. That is 1 by 1 plus 1, 2 by 2 plus 1, 3 by 3 plus 1, 4 by 4 plus 1, 5 by 5 plus 1, 6 by 6 plus 1. So the maximum value you can take is 6. The minimum value you can take it 1 here. So I will write this set as some y is a collection of all those elements such that x is equal to n by n plus 1, where n is between 1 to 6. So if you take the value as 1 here, it is 1 by 2. If you take the value as 2 here, it is 2 by 3. Like that, the maximum value you can take it 6, so that the denominator becomes 6 plus 1, 7. So like this you can denote. And the conventions of n here can also be written in many ways. We can use it strictly lies between 0 and 7. We can also put n belongs to 1, 2, 3, 4, 5, 6 like this. So any one of the conventions can be used for n. Next, write the following sets in roster form. So we have all the collection of sets in set builder form. We need to write it in roster form. First one, such that x is an integer and lies between minus 3 and 7. So between minus 3 and 7 we need to take. When I include equality here, you should take minus 3 as well as 7 also. That means you will start from minus 3 and end until 7. That is why we need to write only the integer between minus 3 to 7. That is after 3 and before 7. So clearly we can write here minus 2, minus 1, 0, 1, 2, 3, 4, 5 and 6. So these are the elements of the given set. Next, set B is equal to x such that x is a natural number less than 6. So always natural number starts with 1 and less than 6 means we can take until 5. Next, set C is such that x is a 2-digit natural number such that sum of its digit is 8. We need to take 2-digit number. So when you add those 2 digits, the sum should be equal to 8. So clearly we can take 17 as the first one because 1 plus 7 is 8. Next we can take 26, 35, 44, 53, 62, 71, 80. 80 is also 2-digit number where 8 plus 0 gives you 8. Next, x is a prime number which is a divisor of 60. We need to see the factors of 60 or divisors of 60, but that should be only a prime number. So therefore the set D contains the elements 2. 2 divides 60 and 2 is a prime number. 3 divides 60, 3 is a prime number. 5 divides 60, 5 is a prime number. Other than these 3, all are multiples of 2, 3 or 5, hence they cannot become a prime number. So therefore the only elements are 2, 3 and 5. Next, set E is the set of letters in the word trigonometry. So when I say the letters of the word, you need to write only the letters once in a set. So therefore T, comma, R, I, G, O, N. So M, E, T is already written, R is already written, Y. Next, set F is the set of letters of the word better. So we can write B, E, T, R. So these are the elements of the set of the word better. Next we have write the following sets in the set builder form. Previously, we have seen this description, that is the set builder form into roster. Now they have given in roster form, we need to write it in the set builder form. Always start set builder form in this way, x is to x, and then write the condition. So we have here 2, 4, 8, 16, 32. Clearly this is 2 and 2 square, 2 cube, 2 power 4, 2 power 5. So we can clearly write here x is equal to 2 to the power n, where n value lies between exactly from 1 to 5. So 1 to 5 means 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5 will give the elements of this set. Now here also they are all multiples of 5. So therefore we can write here, or powers of 5 we can say. So x is equal to 5 to the power n, where n lies from 1 to 4, because the last term is 5 power 4, which is 625. Next we have 2, 4, 6. Clearly you can see the next term you can decide 8, 10 like that. So we can clearly write the set of even integers, or we can say the set of even numbers. Next 1, 4, 9 until 100. Clearly you see 1, 4, after that 9, which is a square number, and the last 100. So we can write here the perfect square from 1 to 100. Next we have 3, 6, 9, 12. Here we need to use this condition, x is to x. This is 3 2s are 6, 3 3s are 9, 3 4s are 12. Hence we can write x is a multiple of 3, where n can take the values from 1 to 4 only, because the maximum value we have is 3 4s are 12. Next we have list all the elements of the following sets. So again they have given the description in the form of set builder. Now we need to write the elements now. So A is x is an odd natural number. When I say odd natural number, clearly we can write this set as 1, 3, 5, etc. Because odd numbers are infinite, so that's why we can end the set like this. X is an integer, minus 1 by 2, 9 by 2. When I say minus 1 by 2, it is minus 0.5, and x should be integer, 9 by 2 it is 4.5. Clearly we know minus 0.5 and 4.5 is not an integer. We need to write the integer between them. So therefore the answer for this is 0, 1, 2, 3 and 4, because clearly they have said that x is an integer. Next, x is an integer, x square is less than or equal to 4. What values of x can take that is less than or equal to 4? That is, x square should be less than or equal to 4. So that means we can take the values from minus 2, because minus 2 square is 4, which is less than or equal to 4, minus 1, 0, 1, 2. We can't take minus 3 and plus 3 because their square is greater than 4. Next, x is a letter of the word loyal. So when I say loyal here, so do not repeat the elements inside the set L-O-Y-A. So I previously told you, you should use capital letters to denote the set and small letters to write inside the set. Don't worry, if it is in this case, you can use the capital letters inside the set. X is a month of a year not having 31 days. So what are the month? You cannot have 31 days here. So that is set E is, so Feb, April, June, September, November. So these are the month which cannot have 31 days in a year. X is a consonant in the English alphabet which precedes K. Means you need to write all the consonant which precedes K until K. So therefore F, we can't write A, we can write B, C, D. We can't write E, F, G, H, I we can't write. We can write J. We can't write K because they clearly said it precedes K. So behind K. So these are the consonants in English alphabets. So this is how we will write the set in two forms. One is the roster form and the another one is the set builder form. We'll meet you in the next session with few more concepts in the chapter sets. Until then, keep watching, keep learning, keep exploring. Thank you.